heterogeneity that they were talking about. You know, properties are changing as you move from one point to another point in the reservoir, the properties are changing. So in this case, you see permeability changing from 3.58 to 2.7 to 2.7 to 3.12. And if you go to the next layer, you're seeing 4.5 and, you know, all this kind of stuff, right? That's PAM-X. The same thing goes for PAM-Y. If you look at this information, generally, we assume that PAM-X is equal to PAM-Y. Take note of that again. PAM-X is equal to PAM-Y. That is the areal permeability distribution. You now begin to see some kind of differences. Excuse me. When you go to PAM-Z. So what you are going to notice is that PAM-Z is a fraction of PAM-X. Did you notice that? PAM-Z is a fraction of PAM-X. Okay, take note of this. It is a question. We're going to get the answers later or tomorrow. What fraction of PAM-X is PAM-Z? So if PAM-X is a 3.583 and PAM-Z is 0.3583, what is the relationship between PAM-X and PAM-Z? We already know the relationship between PAM-X and PAM-Y. We say PAM-X is assumed to be equal to PAM-Y. All right? So PAM-X and PAM-Z, what is the relationship? Please take note of that. We're going to be coming back to that answer later today or tomorrow. If there's time today, fine. So porosity, it doesn't have a relationship with anybody. It's just there on its own. So this is the porosity distribution in your reservoir for all of the cells, all of the grid cells. All right, and here, the next thing you have is the sizes of each of the grid cells, the location, the X coordinate and the Y coordinate of each of those cells. Again, I'm going to leave this the way it is. And here you have your faults. Okay, there are no faults here. Okay, basically what you are interested in here is the properties, the geometry. If you have faults, fine. And down here, operational keyword. You would want to enter this keyword to insert this keyword into your simulation model. I'll tell you why. Again, I'll just notice somewhere. You can ask me later on. I'll tell you why later, but let me quickly show you how you enter that into your simulation model. And of course, that is how you enter the, okay, I think, let me leave it for now. I don't want to mix too many things up at the same time, okay? Are you following or am I too fast?
Sir, you are going just fine, sir.
Okay. Does everyone agree? Okay.
Yes.
I'll assume that everyone. Okay.
As it says, it's following.
Agrees with that. Okay. Okay. All right. So I'll come back to how those things are entered. So for now, again, I am going to close this. Remember, we imported a data file. Okay. So I am going to close this one now. I'll close this one as well. I won't save anything. The same thing applies when you come to the PVT section. You come to section and keywords, and this one will reveal all the keywords. These are the descriptions. You have your water PVT properties, you have your oil PVT properties, gas PVT properties. You can view the keywords by coming to view keywords, and then you see the keyword for water PVT property is this. For oil, for gas, PVDG, and then the densities. So whichever one you click, you're going to see a table. So this table is telling you the behavior of each of the fluids at different conditions. Sorry about that. I'll go back. At different conditions. So, for example, you have this first column here in this table, which is RS. RS stands for dissolved gas. The P bulb stands for bubble point pressure. You have your formation volume factor and viscosity. So you notice that as pressure is changing, the formation volume factor is changing, the viscosity is changing, and different amounts of gas is dissolved in the oil at different bubble point pressures or at different reservoir pressure, as the case may be. So when we talk about PVT modeling or the PVT of your reservoir fluid, you are basically talking about creating this table. Okay. All right. Before we start talking about how to create this table, I'll close this. We're coming back to this shortly, and this time we're going to be very, very fast. All right. So I'll close this as well, and then I'll close this as well. Okay. So this is the project we created. Now I'll take you to the folder where we have the data. Okay. So this was the project we created, right? The empty project we created earlier, exercise 1.off. Initially, this folder was empty, but because we have imported all those information, we now see all this data, right? In Notepad. Do we understand? Everyone understands this? Okay. Now that's how to import an existing data file into your project. Now, how do we create our own data file? Before that, I want to show you what a data file is. I'm going to be sharing this folder with you, these two folders. The grid exports, which represent the information that's exported from the static model. And then these functions, it talks about your PVT and your rock physics, that is relative variability. Okay, what I want to show you right now is a data file. Let's quickly, take a few seconds to look at a data file. Now, can someone tell me the extension, the file extension that I am looking for? Because we are looking for a data file, we want to open a data file. What is the file extension for a data file? Anyone? Anybody? No, not dot text. Yes, dot data. Perfect. Dot data. Okay, that means we are following. So let's go on to look for the file with dot data extension. Here it is. You see, we have this file class_2, and the type of file is dot data. So this is our data file. The first one here is the Eclipse Office file. So I'll go on to open the data file. You can easily open it with a notepad. It's a text file, by the way. So we have different sections here. Look at this first section. It's called run spec section. That is the case definition section. That is where you define your section. So take note. I want you to learn the number of sections that are required to run or to initialize a simulation model. So this is a section. This keyword is a section. Those guys that took the course, the Udemy course, are they here? Are they here?
Sir, it was
Yes.
Sorry, what was it? The 5 guys that won the Pedro challenge, sir?
Yes, are they here?
Yeah, just I think 3 of them are here, sir.
3 of them. Okay. Okay, we shouldn't waste time, but I actually wanted to ask any of them if they learned about the data file already, or they have not started. I explained the data file, how to write a data file, to an extent, depth in that course. So I wanted to ask them if they looked at that. What is Y1, Y2, Y3? I don't know where you saw that, but we'll come to that. Okay, data file. So for data file, we have the run spec, which represents your case definition. That is where you begin to talk about title, your start date, your units of measurement, your fluids, and all that. So anything you see here that is written in block letters, capital letters, is a keyword. So go on and try to match what you have here with what you have in Eclipse Office, and that will give you an idea what each keyword represents. Okay, so this is the case definition section. Title is a keyword to enter your title. Start is a keyword to enter your date, your start date. Metric here, it means you're working in metric units. If you have selected a field unit, you can have it here. By the way, you can make some adjustments from here if you know what you are doing. For instance, if I change this date here to 2021 and I import it into my Eclipse Office, you're automatically going to find 2021 in the date there. So you have this fluid, gas, oil, water, dissolved gas. These are all keywords. Anything capital letter you see here is a keyword. Okay, so this is a section, run spec section. I want you to take note of that. And if you come all the way down here, you have grid. This is also another section, the grid section. And props. This is the props section. Under the props section, you have your PVT and your scar sections. I don't know if I should call them subsections, but you need to learn that. Then you have your solution section, which is where you enter the initial data. So that is where we're going to get to today. So take note again, that should be like question number 3. You can submit your answers to Destiny. How many sections do we need to initialize a simulation model in Eclipse? So pick all the sections between here and here. Forget about these 2 other sections for now. So take note of that and count it out. I'm going to share this information with you later. So that is the data file in, very quickly. So I'm going to be sharing these 2 folders with you, the functions and the grid exports. I should take them from here. Let me put them in this place. I'll close this. I don't want to save. I don't want anything. I want us to start afresh. So I'm taking all of this out. I'm dropping this 2 input data. Then I'll create my folder once again. So this one, I'll call it exercise 2, okay? So I'll go back to Eclipse Office. Let's close this. You can see we're starting afresh, but this time we're going to move very, very fast, really very fast. Okay, so this is Eclipse Office, file new. File new, I am saving them here in this folder, exercise 2. So I'll call this exercise 2.off. I'll click on the open button. So the last time we came here to do this import and all that, okay? But we're not going to import any data file. I want to build our own with the spirit of data that we have. Those data sets are from a static model, the grid and the other stuff. So I'll come here to data, case definition, black oil. I'll call this one exercise 2, all right? I want to retain, should we retain this date? No, let's call this 2021. Let's work in metric units because the information are in metric units, okay? Here, I'm going to leave this blank for now because I don't know the grid size yet until I import the grid data. So I'll leave it blank, is allowed. Then I'll come to reservoir. We might be adding aquifer. So let's add it to the run spec section. Remember that the case definition section is a run spec section, okay? So aquifer, selecting every option possible, and that's the only thing I'm going to do here. Number of reservoirs, 1, that's fine. So I'll come to the PVT section. I'll select oil, water, gas, and dissolved gas. This should be all for this tab as well. I'll come here and select endpoint scaling. And that's all. That's all I want to do. So I'm going to click on the OK button, and that saves everything. So if you come back here, we are seeing all of the files that we selected. So I'll go to the grid section. Now, the grid section is empty. We don't have anything here, but we have some data. So I will import the data. I'll come to File. I'll go to Import, New. Take note of this. The first file you are going to import into this section, you import it as a new file. Go into the grid export folder. Please, if I am too fast, let me know, but I really want us to go over this quickly. So the grids export folder. Someone is trying to say something.
We are good to go, sir. Move on. Right on, sir.
Okay.
Right on, sir. Right on.
So
sir.
In the grid export, in the grid export folder, you have a couple of information that you can export, you can import, but I want to sort this. I want it to look neat. Let's do it something like this so that we'll know exactly what we are importing. Now, this is the main grid file. Now, the grid file is usually the largest. Okay, the main grid file is usually the largest. Let me quickly show you an example of the grid file in Petrel. By the way, this is Petrel. So I just started it. Let's wait for it to load while we continue with this. Okay, so the grid file is usually the largest. So hold on, please. Hold on 1 second. Yeah, I'm so sorry about that, please. Can you guys hear me?
Yes, we can hear you, sir.
Okay. That was the security guy who's helping me with the generator. Okay, so the grid file is usually the largest, right? It's usually the largest file. And I was trying to open Petrel here to show you an example. So this is how it normally comes, okay? So for those of you that have learned a few stuff in the Udemy course, you must have seen something like this. So when you export this grid file, it's empty. It doesn't come with any property. It's just the sizes and the location of each grid cell. So if you have 1 million cells here, all of the 1 million cells and the information are going to be exported. And that is what you are importing. That is what you have here. In fact, you can open it in Notepad, all right? So if you open it in Notepad, you have all of this information. So what each of these numbers represent is the coordinate, okay? The coordinate of each of the cell that you have here. So if you click on a cell, for instance, just this one that I clicked on, okay, it has down here, you see all of this information. This is the address of the grid cell. This is its volume. This is the X coordinate, the Y, the Z, the depth, the latitude and longitude. So all this information are exported and they are stored in this grid file. Okay. So you don't need to bother yourself about understanding what you have here. There are a lot of information. Okay. So that's the first thing I want to import. So I'll click on it and I'll click on the open button, and it is imported into your project. Then you can go on to import other information. This time, I am not going to select new again. I'm going to select append. Please take note. So you're going to append the other ones. Now we have imported the grids. I want to import permeability. Again, you can open it if you want. And it's almost looking like that information in the grid file. But this time, what you have is permeability information. And this is a keyword, PAMX. Okay. When you get this exported information, probably from a geologist or from someone else, before you start importing, you want to open each of these data files to ensure that the keywords you have are correct, that they actually describe the data that you are expecting to find here. For example, instead of PAMX, in some cases, you might see it like this, permeability X. Yeah, it's also telling you that this is permeability, but this is not the right keyword. Eclipse will not recognize this. And you begin to find that you have a lot of errors, you're having issues importing a simple data into your project. So the first thing you want to do is to go into the project and take a look at all of this information. You can even go for interviews. And for those of you that I'm assuming that you have interest, if you are not working yet as a reservoir engineer, you want to take up a graduate role or something, or even internship, and they just want to test you, and they give you a data set with all these wrong keywords, and you might just end up spending hours without achieving anything. So it will do you a lot of good to just simply go into those data file and ensure that you have everything you are looking for, okay, in those data file. Of course, assuming that you know those keywords. Very, very important. Okay, so I'm going to close this. I'm not going to save anything. We don't need to edit it. So I want to append permeability. So I'll append PAMX. I'll go again, import, append. Okay, I'm going to append PAMY. That's the Y permeability. And then go import, append. Okay. This time I'm going to append porosity. Now there's another file that you have here. It's called NTG. Okay, I'm going to drop this one as assignment, question number 4. When do you need NTG? Or let me put it this way, what is NTG? What is the relationship between NTG and porosity? Okay, let me just leave it like that. So take note of those questions, Destiny, right? Please. Did you get that? Hello?
Yeah, please, you can go on. You're currently not available, but we're taking note of that and we'll get to you.
Okay.
We'll be back shortly.
Okay, all right, fine. Okay, so porosity and the NTG, what's the relationship between them? Okay, so I think I've imported things I need from that data file. So I just come here, subsection, grid keywords, and I'm going to maximize this. So you see what we have imported. We have PAM-X, we have PAM-Y, and we have Poro. Something is missing here. Permeability is a vector measurement when it comes to reservoir data. It's vector. So it means it has X, Y, and Z directions. But here we have just X and Y. We don't have Z. Now I am going to import, I'm going to insert PAM-Z keyword. I'm going to insert it. So I want you to take notice of this process. I've not done this before, and I want to show you how it's done. So I'll come here. This first button below the menu bar is called Insert Keyword. So I'm going to insert, I'll look for PAM-Z. This is PAM-Z. So once I click on it, now it's there, but it's empty. So you can start entering, the value of the probability in this cells one after the other, or because it's going to be too much. I mean, can you possibly enter like information for maybe 10,000 cells? It's not possible. Okay, question number 6. How many cells do we have? How many grid cells do we have in this model? Take note of it somewhere. It's part of the questions you're going to answer. Okay, so to populate this PAM-Z keyword, by the way, the first button is to insert a new keyword. The next one is to delete an existing keyword. And this third one here, you're going to use it to manipulate this keyword. I mean, to add data or to delete data as you like. So you can enter a value here, let's say 0.009, and then you click on apply button. Automatically, everywhere gets populated with 0.009, a constant value. But this is not the type of reservoir we're trying to model. We're actually trying to model a heterogeneous reservoir. So we expect that these values should be changing. So what I want to do, because there's a relationship between PAM-Z and PAM-X, so I am going to copy PAM-X first. So I'll copy it into PAM-Z, and that's it. So what we have here is basically information from the PAM-X keyword. And then I want to multiply it. I want to multiply it by a value, let's say 0.2. And I'll click on apply. So what this is saying is that my PAM-Z is a 20% of PAM-X in every grid cell block, and I'm fine with that. So once that is done, I'll click on the OK button, and then I'll come down here to insert a keyword. The keyword is called init, I-N-I-T, very important. I'll talk about why you need this tomorrow. So this is the init keyword. I just entered, click on the apply button, and we are done with the grid section. So I'll go on to click on close. So to close this main data manager for grid section, it will ask me if I want to save. I'll say yes to save it so that it's going to be added to the folder where our simulation data are stored. Then I'll go on to PVT. Okay, so the PVT it doesn't exist. We're going to create it. So I'll go to section keywords. You have 2 ways you can create this here. You can import a model PVT, or you use black oil correlation. So if you want to use black oil correlation, you come to view and select correlations. Then you see all of this information. There are a whole lot of them. You begin to enter the information that you have that describes your reservoir fluid. But let's not go into this for now to avoid any sort of confusion. So I'll leave the correlation section. In fact, I'll leave the PVT section keywords, and I'll go on to import an existing file, an existing PVT data file. It's in this folder, functions. It's named fluid. Well, you can also open it to view what is there. And it looks like what we have. It looks like what we have in those pages, the one I showed you earlier. So if I import it, this table is going to be imported. So after importing, go to grade keywords, and now we have the data imported into the PVT section. Okay. All right. Once we are done here, again, I'll close this. It will prompt you to save, accept to save, and then you go to the scout section. The scout section also, you can use correlations. When you click on correlations, you begin to enter all of this information. What is query of water? What is minimum water saturation? And all of this. Again, there's no time to go through all of this explanation. It can be a very detailed information, but we have a PVT data model already. So we'll just go there to import it. So I'll close this. I'll come to File, Import, New. And this is it, rock physics. Can also be opened. And then you see the keywords for oil water saturation. As water saturation is changing, the relative permeability of water is changing, the relative permeability of oil is changing, and all of them, they tend to describe the mobility behavior of the fluid in the reservoir. And this is also a function of capillary pressure, PC, okay? So we have a gas and oil saturation function as well. Here we have gas saturation, relative permeability of gas, relative permeability of oil, capillary pressure, 0 for gas, oil. Okay, so here I'll just go on to import it. And if you go to keywords, you find everything that has been imported, right? There's an error here. It says data must be, it's showing an error down here that data must be monotonically decreasing. What I am going to do is this. Please take note and do it in case you begin to have this error. Put 1 at the first line, delete everything else. And then come here. Oh, I think there's a very big problem. There's a very big problem with this data. Let me look at it more closely. Okay, so we have 6. Why is it not importing correctly? The data is fine. So let me reset and leave here. I'll try to import it one more time. Yeah. I'll try to import it one more time. And let's see. Oh, okay. This first line of data, you can see that it's all zeros. I am going to delete that row. I am going to delete that row. So to delete the row, I click on the row, right click, and then go on to select delete row with focus. So we are good now. So don't bother about entering 1 and 0. This data is fine. So if I go on to click on the apply, now it has taken it. Okay, the same error is here. So I am going to take it off as well. Okay, that's it with the scout section. And then I'll save everything. Then we'll come here to the initialization section, which is the solution section in your data file. So I want to enter the initialization data. You need to bring in a keyword. Take note of this keyword. The keyword is called equilibration data, this one. The keyword is equil, E-Q-U-I-L. So if you view by keywords and you try to insert, so this is it. I think it should be easier. You can remember it better this way. So I'm going to enter this keyword, and then I'll go on to enter the necessary information. The datum depth and the pressure measured at this depth. Those are the two important information that you need in this section. I have them here. So datum depth is 1,600 meter. I'll enter 1,600. Make sure that the unit here is meter. The pressure is 200 bar. I'll type 200 bar. Then you have your oil water contact at 2,600 meter. You have your gas oil contact at 1,600 meters square. Okay, so this is it. This is what you need. There's one more keyword I am going to enter. There's one more keyword I am going to enter. The keyword is called RSVD. This is RSVD. It simply means RS versus depth. RS stands for dissolved gas, and then D stands for depth. V versus. So you are simply trying to tell Eclipse how much oil is dissolved and how much gas is dissolved in your oil at a particular depth. So I'll select it. I just need 2 lines of data. All right. Maybe I don't even need it because I have defined my datum depth at the GOC. So I probably don't need that. So let me just take it off. Let me take it off. Okay. So I have my datum depth at GOC. So that one handles information about the amount of gas we have in solution. Okay, that's all. And then I'll go on to close this and I'll save all of that. So we have entered all the information that we need for to initialize the simulation model. I want to request for some results, some simple results. I'll come here to keyword types. Take note of this step again. If not, you might finish running your simulation and you don't find results. Keyword types, and then I think it's miscellaneous. Then I am going to enter RPTSOL. Look for the keyword, this one. RPTSOL is used to report your solution. Okay.
Hello, sir.
So this is the keyword RPT.
Hello,
Yes, go
sir.
on, please. I can hear you.
Okay, sir. I think we are limited by time in here, so I don't know.
Rounding up.
Yeah, so
I'm rounding up.
you could take up to 520, sir.
Okay, I'm rounding up actually.
Yeah.
Okay, so to report your solution, all right, you bring in this keyword RPTSOL, and even in this bracket, you're saying initialization print output. Okay, so with this keyword, you'll be able to output your solution. So under it, I'm going to type a few more commands. I'm going to type basic equal to 2, and I'm going to type FIP. I want to know my fluid in place. So I'll type FIP equal to 2, and then I'll terminate that command line with a slash. You can copy this information somewhere so that you can use it directly in your own simulation model. Okay, so this one will help me to generate the fluid in place in my simulation model after I finish running the simulation. And that's all with initialization. So I can now close and save this file. So once that is done, I can go on to close this as well. And one final step. If I click on File and I say Write Data, that's all. So I can close everything else now. I can save my project. Before I go on to run, I want us to quickly view what we have created. So this is exercise 2, and that is everything we have created. So I want to view details once again. So if you come somewhere down here, you're supposed to see a data file. This is the data file that we just created in this project with Eclipse Office. So after all of this process, this file becomes a very important part of the work you have done. Okay, we are coming back to locate this file. So we want to run simulation. I can click on this button to start running my simulation, and this is like the very easy part, but I want to go the other way. I will simply come here to the simulation launcher that I talked about earlier. I'll click on this option here, which says Eclipse, that is E100. I'll come here to add data set. So from the add data set, I'll go on to that folder, which is here. And this is the data file. Example, exercise 2 underscore E100 dot data file. So if I click on the open button, and now I am ready to run the simulation. All I just need to do is to click on this button, and you see the Eclipse console pop up to show you that the simulation is running. And you just have to give it a few seconds or some minutes, depending on the size of your grid. So you want to ensure that the message you are getting shows that you don't have any errors. So because there's 0 errors, it means the simulation has completed successfully. So I'll close this, and I can minimize this. Now let's go on and see the result that we requested for. We requested to view fluid in place. So to view the fluid in place, I'll go back to my folder, and I'll look for a PRT file. That is another type of file with the extension PRT. You see? So this file will contain all of the results from your simulation run, whether errors or warnings or anything at all. So you can open the file. When you open the file, you scroll down, you see everything you have entered into the simulation model is documented here. And you can go all the way down to see FIP. You see, this is field totals. So you will see the liquid that you have in this field, that is liquid oil. Liquid oil is this figure, vaporized oil is 0, the total is 0. This, I think that's about 341 million cubic feet of oil. That's a lot. And then you have this amount of water, and then you have 0 free gas, and this amount of dissolved gas. Okay, so that's it. We have just initialized a simulation model with this information, this grid export from the static model, and with this fluid and relative probability data. And then this is the result that we have. There are no errors. Okay. So I'm going to be sharing this data set with you guys so that you will be able to perform this kind of a simulation run by yourself as well. And I want you to be able to get this result. Then I am going to give you one last question as an assignment. I want you to list, in case you run your simulation model, you build your project and you have a different volume. Let's say you have twice or half of this volume. What do you think would be responsible for that? So I want you to list, do simple researches. I want you to list a few parameters or properties of your simulation model that can possibly affect the volume results that your simulation model produces. And we have come to the end of this meeting. Any questions?
Yeah, if you have questions, please use the chat box to send your questions. Okay. Thank you very much, sir. This this session was really very good, interesting, and it was really amazing, sir. I really love this session. And in fact, I wish we could continue, sir. It's really you really made it very simple, and I see some person saying exactly the same thing in my mind. The way you took your time to explain everything, you made it so simple, and I'm so grateful, sir. And I believe the participants are too. So it's really an amazing lecture. So yeah, so we should all be preparing for tomorrow, tomorrow's class, and for the recorded videos, it won't come immediately. It will come by next weekend. So you should prepare for that. That is why you should also try as much as possible to follow through in the class. Tomorrow's class, I believe, will even be more amazing than this. I don't know, is there a class that could be more amazing than this? If there is, then I guess that will be tomorrow's own. So before you go, please let me just reiterate some of the things I said. Since I've not seen any question that it's related that I'm supposed to ask or that was directed to our instructor. All I see is thank you, sir. Thank you for the great lecture, amazing lecture, and all those wonderful comments. So those asking about getting the data sets, don't worry, just become, you'll get it. Yeah. So please take notes. Your assignments, we'll send you the assignments. Those who have paid for the certificate, you'll be able to submit the assignment via Google Classroom, and you are the only ones that will be given certificates. The certificate is only for those who finish the assignment and also make the payments. So please take note of that. And tomorrow we'll be starting by this same time. Please come online on time so that you'll be able to follow through with the class. A number of persons came late and they weren't able to catch up. Please come on time, come online on time so that you'll be able to follow up with the class. Invite your colleagues and friends to also join you. Thank you very much for learning with us. Engineer Joseph has almost 10 years or 8 years, if I'm not mistaken, experience in reservoir simulation. He has an amazing course on Udemy, a more detailed and complete course. You might want to visit it, or if you want to reach out to him if you want to reach out to him privately, you can just contact me. Yeah, so you might want to probably have some important things you want to discuss with him. Just reach out to me as he has directed you, and I'll connect you with him. Thank you very much, guys. I hope to see you tomorrow. And yes, one more thing, please, guys. We are extending the deadline to tomorrow, Sunday. So if you have not paid, you have till tomorrow to pay. So we are adding an extra 24 hours. Please, you have to pay within the time limit. Beyond that time, you have to pay $10, right? So if you go beyond the time tomorrow, you have to pay $10. So it's just $5 right now. But if it goes beyond tomorrow, you have to pay $10. So take note of that. Thank you very much. Feel free to communicate with yourself in the group chat to interact with yourselves. Ask any questions you have and get responses, and respond to others too as well. Thank you very much. Hope to see you guys around. So thank you very much for the class, Joseph.
Thank you. Thank you. All right, now see you tomorrow.
Thank you, sir.